Hello everybody. In a previous video in Home Labs, we developed an Arduino controlled Ferris wheel. The code for this Ferris wheel was tested on a website wiki. This website is for simulating IoT projects in your browser. Here's a project on wiki. On the left side is the code window and on the right side is the circuit. When I start the simulation, you can play around with the buttons and watch the circuit in action. So you can notice that in this little simulation, we do not have the LM293D or the DC motor. The reason for this is that this website does not have the motor or the motor driver. This video is a brief tutorial on developing code and testing it out on wiki. So let's open up a new project for ourselves. You can zoom and pan using the mouse buttons. Let's add 3 push buttons. I change this to black and this to yellow. All the 3 get connected to ground. I change the wire color to black. I change the colors. So there you go, we have set up the push buttons. I now add the I2C LCD. This goes to 5 volts and this to ground. SDA goes to A4 and SCL to A5. I toggle to more exciting colors. So the push buttons and the LCD screen is being set up. So now let's try to develop the code stage by stage. So AVR interrupt.h is essential to enable the pin change interrupts. We include the liquid crystal library. The LED pin 13 is used for indication purposes, and so we declare it as a constant byte. This is a boolean variable which is going to be toggled inside the interrupts, and hence it's declared as a volatile variable. Here are the pins 8, 9 and 10 on which the pin change interrupt shall be configured. And the purpose of this code is to just initialize the LCD. So we run this. And there you go. The forward S and 0 PWM is printed. The next step is to add the pin change interrupts. So this part of the code enables the pin change interrupts on pins 8, 9 and 10. And this pulls up these pins to high. I save the code and run the simulation. Well, the interrupt's getting triggered, but nothing exciting is happening. Step 3, we add something to the interrupt vector. We add a few indicator variables which are going to be toggled around in the interrupt vector. I added the interrupt service routine. I save the code and run the code. So now when I press this, the interrupt service routine is getting triggered, and you can notice that when this is getting triggered, then increment is getting set to false, and when this is pressed, this is getting reset to false, and when I press this and the speed happens to be 0, forward would be toggled from forward to backward. So the idea of the code is that in the interrupt vector, we'll do the minimal changes. We'll do minimal processing. We'll simply toggle a flag. And based on this flag, there'll be a code written down in the loop which would cause the Arduino to take certain actions. So we now add the variable constant byte steps 5 to increment the speed in steps of 5. We scroll down to the loop and add the if-else loops. So this first loop here, this is going to get triggered if inc happens to be true, and inc would be set to true by toggling the pin change interrupt on pin 8, and if this happens, then the speed would be incremented subject to the speed being between 75 and 120, and it will be incremented in steps of 5, and the code here would write this speed to the LCD screen. There's a delay of 400 to debounce the switch, and Once this delay is completed, then allow this variable is set to true, and this would allow the interrupt to be operated again. So you can see here that the interrupt is triggered only when allow happens to be true. So by introducing this small delay, we are debouncing the mechanical switches which have a tendency to shuttle around between two states before settling to the desired state. This is a loop which gets triggered when ink happens to be false, and this would decrease the speed right up to 0. The other part of the loop is similar to what we discussed just now. And here's a third loop which would flip the direction and print it to the LCD screen. Here's another loop which is going to check if the speed is greater than 0 or not. And if the speed is greater than 0, then this S will be toggled from S to R. So now the state of the motor is defined using whether it's running or not, whether it's going forward or backward or not, and the speed. Save the code, run the function. So when we press this, speed gets incremented right up to 120. Nothing happens after this. We can reduce the speed, flip the direction. So lovely. The code's perfect, but the only thing is we still don't have a motor attached to it. So I added this function to the code. This basically accepts three variables. One is the state of the motor, the other the direction of the motor, and the third is the speed. In all situations, the speed is written to the motor, and in case the motor is running in the forward direction, then forward pin would be high and the back pin would be low, and vice versa in case the motor is running in the reverse direction. In case the motor happens to be stationary, then both pins would be written to low. I also set the initial state of all these pins to low. I now need to add the LEDs. I add three different colors LEDs. Red represents the enable LED. So this goes to ground. Let's add a resistor. This goes to pin 6. Color it as red. This guy represents the forward direction, and I am going to keep it green. Let's make this orange. I forgot to add a resistor here. There you go, the circuit's ready. I save it and run the simulation. Forward direction, the green LED blinks, and as I increase it, the red LED is actually becoming brighter, although it's not very clear from the simulation. So that's a little demo on how to use Wheel-Wok for your Arduino simulations. I hope you loved the video. Do like and subscribe to this channel. Thanks for watching.